Linkoping University is one of the largest universities in Sweden and located between Stockholm and Gothenburg, essentially. We have about 26,000 students, and we are specializing in engineering, mechanical, electrical, design, and so on. We use a lot of computer simulations in the education for the students. Specifically, we're interested in CDIO, the Conceive, Design, Implement, Operate system, where we try to get the students really working on real subjects and making the really large-scale situations where they can work on things that are on an industrial scale. In the research field, we are essentially doing e-science only. Everything is simulation. We are using everything from computer simulations for CFD, as well as electrical engineering, as well as structural mechanics. In our research, we use simulation for simulating blood flow mechanics, for example. We are designing new airplanes and looking at film cooling of gas turbines. So we have a very diverse region of where we're working. We choose Ansys because it's the only code we can find commercially that is really complete in the sense of a mechanical, electrical, and also CFD. And we needed to tie those things together with the students. One of the reasons why we choose Ansys was to actually be able to have the same tool for different types of problems. We're using the Ansys tools as an introductory course already in the second year of the mechanical engineering student, so that get used to the finite element method, and then they can use it as a tool in any other course they continue taking. It will be like a MATLAB for them, something that they will launch very simply and then work on their projects. In the research, it's used in many different fields, everything from biomechanics to aircraft engineering to industrial heat transfer problems and so on. We use it a lot and in all the disciplines, and particularly because we can use the same tool everywhere, it's very well received. We have a lot of collaborations with the industry, both the local industry like Siemens gas turbines and Saab aircraft, but also from places like Tetra Pak and so on. So it's a large collaboration with industry in the whole country. One of the really interesting recent things we've done is look at cholesterol, and we're trying to find cholesterol in medical terms will be known as LDL, or low density lipoproteins. And what we've been doing with Ansys is to simulate the cholesterol depositing on the vessel wall by using a fluid structure interaction model, where we have a turbulence model for the flow and a hyperelastic material wall model. And that means we can actually look at how the cholesterol is now deposited throughout the heartbeat, which is sort of a revolution, because now we want to see the real details of atherosclerosis. One thing that's interesting in terms of what we can do with CFD coupled with structural interaction is to compute wall shear stress, which is actually unmeasurable. So even if we have a magnetic resonance scanner to measure flow or some other device, we cannot measure the wall shear stress itself. It has to be computed. So we come up with a way using some fluid simulations with some fluid measurements and combine them together to actually measure these or compute the wall shear stress. One of the most recent things we've done is to invent an airplane that has no tail, like a bird, if you like, and we can now actually compute things like we have a pitch up, pitch down with just moving the wings. So it looks like a seagull and it seems to fly. So we're really interested in trying to find out what we can do with the next generation airplanes.